Most chemical reactions produce configurational isomers. There may be two products, endo and exo. This is benzonorbornadiene molecule. When its epoxidation takes place, two products are made, endo and exo. This is a bridging carbon in the ring, this one, and this is the double bond. So when m-CPBA metachloroperbenzoic acid reacts with this molecule, this double bond breaks and oxygen attached with these two carbons, this one and this one. So the epoxidation has taken place and now we have an epoxide. The oxygen is attached here after the breakage of double bond. This red one is the oxygen and the double bond has broken, and this is the bridging carbon. And if the oxygen and the longest bridge, this is the shortest bridge 1 carbon and this is the longest bridge 6 carbon. If the oxygen and the longest bridge are on the same side, let's see, these are on the same side, so this is an endo position when the oxygen and the longest bridge are on the same side. You can see in another way that the shortest bridge and the oxygen are on the opposite side, but the more correct the definition that I have seen, that most of the time they count the longest bridge. If the oxygen or any R group that is near to the longest bridge, this is an endo position. This is an exoisomer. In the exoisomer, the R group or oxygen is attached here, so it is far away from the longest bridge. Let's see, this oxygen is away from the longest bridge, so this is an exo position. The oxygen and the R group or the shortest bridge are close to each other, but the R group or oxygen, this one is far away from the longest bridge. So whenever you have to identify the exo and endo, please look at the longest bridge and the R group, where the R group attached. If it is away from the longest bridge, then it is an exo. If it is near to the longest bridge, then it is an endo isomer. Thank you.